Okay, for the costs, there are a number of important concepts here. First, we have fixed cost, which is the cost associated with the fixed input, which is capital. And we have variable cost, which is the total cost of using the variable inputs, that's labor. So the total cost is just sum up the fixed cost and the variable cost. So we can calculate average fixed cost, which is total fixed cost per unit of output, total fixed cost divided by quantity. We can have average variable cost, which is the total variable cost divided by quantity. And also average cost is just total cost divided by quantity. Importantly, here an important concept is the marginal cost. So now the marginal cost is the change in the firm's total costs resulting from a unit change in output. So if output increased by 1 unit, what's extra change of the total cost or total variable costs? So we have, say, a cost function C as a function Q. Then marginal cost is change of total cost divided by change of quantity, or in terms of differentiation is I'm using the differentiation dc over dq. Okay, that's the marginal cost, and this is important. One of our tasks is to decide how many units of output should we produce in order to maximize profit. In doing so, we need the marginal costs. Okay, let's look at the examples. So here is the first column is quantity. If we produce 0 units output, because we are in the short run, so there's still cost associated with the capital. That's fixed cost. It's $100, let's say. And certainly there's no variable cost. Total cost is just $100. If we produce 1 unit output, we need to hire optimally additional workers. So suppose total variable cost is $55.7. So we can work out the total fixed cost and get the average fixed cost, which is total fixed cost 100 divided by 1. Okay, average variable cost is 55.7 divided by 1. Okay, average total cost is 155.7 divided by 1. And marginal cost, so we go from 0 to 1, the total cost increased from 100 to 155.7. So marginal cost of this unit is change of quantity, a change of cost, so is 155.7 minus 100 divided by change in the quantity, so 1 minus 0, so it's 55.7. Okay, so on and so forth. We can work out the whole tables. Then, using the data of this table, we can plot a function, the cost function, as this. So this is total cost as a function of quantity, and the total variable cost, total fixed cost, as a function of quantity. And this is average cost, average variable cost, and marginal cost. And the example here is a typical in the example, in this particular numerical examples, the cost, the shape of the cost function, total cost, total variable cost, marginal cost, average cost. average variable cost. They exhibit a typical shift. That is total cost is initially increasing at a decreasing speed, then more or less constant, then eventually no diminishing return kick in. So it is increasing at increasing speed. Or this is concave, this is more or less linear, this is convex. Okay. For the marginal cost, average variable cost, they are first observations, they are U-shaped. Initially decreasing, then eventually increasing. And eventually increasing is because of no diminishing returns. Second observation from this diagram is that marginal cost curve cut through the minimum point of average cost and average variable cost. Why that's the case? So it's this point. So before this point, we see that average variable cost is above the marginal cost. What's the marginal cost? Is the actual cost associated with actual 1 unit of output. So now, since the old average is higher than the new actual cost, so if we add this unit n, then the new average decrease. So average cost decrease. If after this point, after roughly 6, now marginal cost is above the average cost curve. So in such case, in this drawing, one more unit, if we produce one more unit output, the actual cost is higher than the old average. So if we add this unit into the pools, the new average will increase. Okay, so that it increase. So it increase after 6. So this means that it cuts through the minimum point. Marginal cost cuts through the minimum point of average cost curve. Right, so here's the important observations. Average fixed cost declines steadily over the range of production, which is not surprising. The more you produced, and the average fixed cost decrease. And generally are U-shaped. And marginal cost cuts through the minimum point of this, of the average cost and average variable costs. And the distance between average cost and average variable cost eventually decrease. Okay. Right. Okay. So this is the concept of marginal cost, average fixed cost, total fixed cost, and variable costs. And in particular, we will need marginal cost in answering how many units output should a firm produce.